Section 3.2, we're going to look at least squares regression. So the concept of a regression line is something that you've seen in other classes. Algebra 1, Algebra 2, we have a scatter plot. We want a line that, as best as we can, describes the pattern of this data. Okay, in this class, this is the form we're going to use. Y hat equals a plus bx, and we put a little hat over the y to indicate that this is a predicted value. Okay, and so nothing new here. Can we use the equation to predict the price? All right, so we have our equation for price hat, which is the predicted price based on miles driven, comes from this scatter plot and this data. Okay, and so if I want to know with 100,000 miles, I just plug that into my equation and there's my predicted price. Okay, now if we look at a truck that has been driven for 300,000 miles, okay, if I plug in 300,000 in that equation, I get negative 10,613. All right, so that would mean that I would have to pay somebody to take my truck from me if it had 300,000 miles on it. Okay, what we just did here is something called extrapolation. Okay, and that is we used an x value that was outside of the data that we used to make the prediction. So if we go back and look at this scatter plot, we're looking at trucks very close to 0 miles driven all the way out to, maybe 150,000 miles. That's the data that we use to create this line. And then we plugged in 300,000 miles, which is more than double the largest value in our data set. So when we use numbers that are that far outside of the data, we can't say that that is necessarily accurate, okay? Because I don't know that this pattern is for sure going to continue if I get out to 200, 200, 250, 300,000 miles. In fact, my answer indicates that it probably doesn't because I'm not paying somebody $10,000 to take my truck. Okay, so that is called extrapolation, and we got to be very careful with doing that because we can't be sure that the pattern holds. Okay, something else that we like to look at is called a residual. Okay, remember we are drawing these lines, and of course they don't go exactly through every or maybe even any of the data points in our line. And so a residual is the difference between the actual value and the predicted value. So it's just that vertical difference between my regression line and the actual points in the data. Okay, so the direction that we're going to subtract is actual y minus predicted y. Okay, so if I have a positive residual, it means that my line predicted a number that was lower than what actually happened. And if I have a negative residual, it means that my line predicted a higher value than what actually happened. All right. So we're going to calculate and interpret a residual. Okay. So first thing we need is the predicted price. So we get that by plugging that 70,583 miles into my equation. And this is the predicted price. Okay, the actual price is given to me in the data, and so I'm going to find the residual. I'm going to subtract the actual price minus my predicted price. Okay, so the actual price in the data set was 21,994, so that gives me a residual of negative 4,765. Okay, and so now let's interpret that residual. We have a template sentence that you can use. All right, the actual y was whatever the residual is, and then say above or below. Okay, if the residual is positive, it's above. If it's negative, it's below. Okay, so for this one, the actual price of this truck was $4,765 less than the cost predicted by my regression line. Okay, so because my residual was negative 4765. We also need to be able to interpret the different pieces of the regression line. And so that would be the y-intercept and the slope. If you did this in Algebra 1 too, they probably did y equals like mx plus b or bx plus a or ax plus b, whatever the letters are, doesn't really matter, okay? We just got to pay attention to, we have a y-intercept, a constant, and then my slope is the number that is divided by or multiplied by x, okay? So when we do this, we have sentences again for interpreting slope and y-intercept. All right, so here's kind of your templates. As always, not looking for word match, but just that you are getting the general sense of what the sentence is saying. Okay, so we want to interpret the slope. Here's my slope, the number that I'm multiplying by my x value, miles driven. Okay, so the predicted price of a used Ford F-150 decreases by 0.1629 for each additional mile that the truck has been driven. Okay, then when we get to the y-intercept, we have to first make sure that this value actually has meaning. Okay, so sometimes the y-intercept is a meaningful number and sometimes it's not. So in this example, I could have a truck that's been driven 0 or near 0 miles, right? A brand new truck has 0 miles on it. So the y-intercept does have meaning in this case, so I can go ahead and write my interpretation. Sometimes the y-intercept will not have meaning. If I had an equation that was looking at, let's say, birth weight of babies, okay, the y-intercept there would indicate that I would have a baby that was born weighing 0 pounds. That's not a thing that can happen. So in that regression line, the y-intercept does not have any meaning in that context, okay? The other thing is to make sure that you are using the word predicted or some synonym of the word predicted, so that we know that you know your regression equation is a predicted value and not the actual value. All right, so the line that we are going to use is called a least squares regression line. The reason it is called that is because, and again, you're not going to have to do this math, the calculator or computer is going to do it for you, but when they make the line, they draw the line so that the square of the residuals, so they take the residuals and square them, and they are drawing the line so that that number is as low as possible. Okay, again, not something that you need to know how to do, but something that you need to understand about the line. So the equation that your calculator or the computer output that you see gives, that's how they decided how to draw that line. It's to make the sum of the squared residuals as small as possible. All right. Now, you will not have to sum residuals and do that, but there is a way to do to find a regression line using summary statistics. So if we have the mean and standard deviation for both our x values and our y values, we can use these two formulas to come up with the least squares regression line. And so let's look at an example. All right. So the first thing I'm going to do is find the slope, which is equal to r, the correlation, times the standard deviation of x divided by the standard deviation of y. Okay, and so I plug those numbers in and I get negative 0.422. So that's going to be the slope of my regression line. Then I'm going to find the y-intercept, which is y bar minus bx bar. And remember that y bar and x bar are the means of my explanatory and or response and explanatory variable. Okay, so again, plugging those numbers in. Then when you write your equation, so my equation is y hat equals, and then I use my y-intercept and my slope, and we always have to define the variables that we are using. So y hat in this context is the predicted SAT math score, and x is the percent of students on free and reduced lunch. Okay.